So today we are starting lesson 9.5, which is polygons on the coordinate plane. As we remember from yesterday, polygons are any two-dimensional enclosed shape made with only straight lines. So, this is not a polygon. This is not a polygon, but that is indeed a polygon. Any two-dimensional figure that is enclosed with only straight lines. So, our warm is on page 705. If we look at 705 here, it's giving us plot points to graph. Who can tell me what they think vertices means? What do you think vertices means, Hannah?
Like the points on a shape.
Points on a shape, that's great. Do we have any other ideas, Ben? The corners, exactly. So they are the points of the shape, because without those corners, without those points, we wouldn't be able to accurately draw the shape itself. So the vertices are always what's known as the corners, they're a specific part of the shape. So, first things first, we have our stage. Now, when I graph this, the first location of my stage is at 2, 6. Just to practice our graphing, is that going to be here or is that going to be here? Which one? Plot point A or plot point B? I want to see Jaden. He says A. Do we agree? Yes, exactly. It goes X first and then Y, just like our alphabet. So there would be our first plot point. Then we have 2, 9, which goes up there. We have 6, 9, which is here. We have 6, 6, which is here. 5, 5, and 3, 5. So as we see, this makes an interesting shape here. And now you're thinking, okay, this doesn't look like any shape I've ever seen the name of. But we count the sides. We count the sides. So how many sides does this shape have, Hannah? 6 sides. Who knows what a 6-sided figure is called? What is it called, Gore? It is a hexagon. It's a hexagon. So then we have our next shape. We've got our next shape. This one starts at 7, 5. So I go to 7, 5. I'm going to pick a different color. That's better. 7, 5. We go to 7, 9. We go to 9, 9. And we go to 9, 5. And if we fill this shape in, I think all of us better know what the name of that shape is. What is it? Let's see, Romario. It's a rectangle. Excellent. We're so on top of this. And then lastly, our last figure is at 5, 2. Then we're at 5, 4. Then we are at 7, 4. And we are at 7, 2. So, let's see. Matthew, what is the name of that shape?
Square.
It is a square. Exactly. So we've got those 3 shapes. We've got our hexagon, we've got our rectangle, and we've got our square. It asks us to find the dimensions of the bleachers. So these ones right here are our bleachers. That's what it says right here. So what is the dimension of the bleachers? What's the length of the bleachers, Ben? Perfect. It is 4 long. That one's hard to see, so once again, I'll pick a different color. It is 4 long. What about the height then, Oswaldo? 2. Our height is 2. So all we did when we were counting this is we just simply counted. So, I don't have the one that I wanted. Okay, so it says the length of the line from point 26 to point 29 is 3 units long. How can you use the y-coordinate in this case to find the length of the line? Who can tell me what they did in this situation? How they used the y-coordinate to find the length of this line? First of all, Gloria, what's the y-coordinate of that first point?
6.
6. What's the y-coordinate of that second point then, Lily?
9.
9. And it says the length is 3. What do I notice there, Gloria?
You subtracted 6 from 9.
Exactly. 9 minus 6 is 3. Let's look back over here at this same shape that we were dealing with. Here we've got 9, and here we've got 7, right? What's 9 minus 7 then, Rocco? 2. Romario, here we have a 9, and here we have a 5. What's 9 minus 5? 4. And look what we found to be the dimensions of the bleachers. So all we're doing is we're measuring the distance between our plot points. Michelle says, in number 1, aren't the length and the height, don't you switch them? The answer is, it doesn't matter. When we're doing our shapes, any side can be our base. Any side can be our height as long as they form a 90-degree angle. So if you would put 2, 4, you're totally chill. If you would put 4, 2, you're totally chill. If you put anything else, that's when you're wrong. So as long as you have those 2 points, and when we're finding area, that's when it matters, as long as they form that 90-degree angle. So here we're looking at this together. Rectangle ABCD has vertices, which are corners, at these certain points. So whenever it tells you this, we know we follow. This point is A, this point is B, this point is C, this point is D. It's not all that important. However, in future math, when you're doing it, you do follow the way that it goes. So for example, it'll ask you, what is the length of AB? And if it has a line over it, that means line segment AB. So here I've got this. I already plotted it because we're all experts already. So we've got our vertex A is at 2, 1. Our vertex B is at 2, 5. Our vertex 3 is at 4, 5. And our vertex D is at 4, 1. So we see all of this. It makes us a nice little rectangle. Now, it asks us, we want to find the length of each side. We can already do this with counting. Here, what's the length of that side? What is the length of that side, Melanie? Perfect, it's 2. We see that. 1, 2. Adriana, how long is this side?
4.
It is 4, exactly. 1, 2, 3, 4. Let's look at this a different way too, though. Our base is going to be our x1 minus our x2, and our height is our y1 minus our y2. Remember, it's okay if you swap those 2 terms. That's totally okay as long as you stick with the same thing. We need to keep our y's with our y's and our x's with our x's. So for example, here we had x1 minus x2, right? We had 4 minus 2. I always put the bigger number first because otherwise you're going to be ending up in the negatives. That's just how it works. When you're picking x1 and x2, pick the bigger number to be first. Pick the bigger number to be first. So for our base, we had our x is 4, as we saw here. Our x is 2, as we saw here, and we got 2, which is what Melanie told us. We got that 2 right there. Adriana said 4. Here, we have 5. We take away 1, and we get 4. You're not always going to be given these shapes on a coordinate plane. You might have this shape drawn just like I have it drawn in that bottom left-hand corner, in which case you can't just count the boxes. That's why we use this. That's why we're using the difference between the vertices to find the length of a segment. Once again, here's how we would do it if we were counting. We had 1, 2 boxes, and then we had 1, 2, 3, 4 boxes. So here, I have gone to page 706, and I'm currently looking at A and B. Now, with these, let's look at this all. I'm looking at my points, and I plotted them all. I've got 3, 6, 3, 8, 7, 8, and 7, 6. So when we're picking this out, we look at our x values. Here are our 4 x values, 3 and 3. If we subtract those, we get a side length of 0. Does that make sense? No. So we're not going to be dealing with that one. What's our other x values that we have? What are the other x values? Rocco. Not 8 and 8. We have 7 and our other 7. because it comes first. So we know that we're going to be dealing with our x values of 3 and an x value of 7. It doesn't make sense if we used 7 and 7. We would get a side of 0. Can't happen. It doesn't make sense if we used both 3 and 3. We would get a side length of 0. Cannot happen. So instead we use the two different x values. So what do we know? What is 7 minus 3 then? What is it, Elsie? 4. And here, I put it on my graph. This one here is 7, 8. This one here is 3, 8, because I'm looking at the two of these technically here. And I got a difference of 4. Here, this 3, 8. Below it, I have a 3, 6. And here, I have a 7, 6. What's the difference between 8 and 6 then, Malia?
8 and 6?
2. Exactly. We have that here. We have our 2 and our 6 there. So for this other one right here, I want to find the length of each side. So I'm going to have you find the length of each side. I'm going to show you how this will be written. So we have our plot points. We have our plot point I, we have our plot point J, our plot point K, and our plot point L. It's important that they match the vertices where they are at. You can't just decide on your own which point is which point. It depends on what their vertices are when we match our vertices. So let's identify the length of our lines. I want to find out the length of IJ. I want to find out the length of JK. I want to find out the length of KL. And I want to find out the length of LI. So it's got that line above it, letting us know that we're measuring the length of the line. Here, I drew our figure out nicely, but I want you to look at the coordinates in your book and tell me if you're able to identify it. We're looking at this first point. We care about IJ. IJ are graphed the same on the x value. So are we looking at their x values? No, because they both have 1, so it doesn't matter. Let's look at the difference between IJ then. What is the difference? What is the length difference, Andrew?
5.
5. And how did you find that?
For the I, the length is 1, 4. For J, it's 1, 9. I subtracted 9 by 4.
Yes, exactly. So he found that I was 1, 4. J is 1, 9, so he just subtracted those values, and he got 5. And let's check. 1, 2, 3, 4, 5. Excellent. He is correct. Number 2, Michelle. What did you get as your answer?
7.
How did you get 7 then? So J is 1, 9, and K is 8, 9. Excellent. 8 minus 1 equals 7. Michelle, how did you know we were going to be subtracting our x values? Yes, exactly. She is telling us that this line side, the way that we're doing it like this, is the same as our x values. We're increasing this coordinate as our x. This is our y. So whenever we're looking at that, we're looking at the side that matches the right coordinates. Remember our rise over run? Rise is y. So when we are rising, we are measuring y. Run, when we are running, we are measuring x. Excellent. Now, for KL, Daniel, what did you get? 5. We followed the exact same thing. Of course it's going to be the same length. We've made ourselves a nice fancy-dancy little rectangle. So, Lily, what's the answer to LI? 7. Exactly. So we follow those same things. We just have to be careful we know what we are subtracting from what. If you are making the mistake where you're subtracting the wrong things, the easy way to avoid it is to check 1 and 1 are the same, subtracting, get 0. Can we have 0 as a length of our side? That is just no side. It doesn't exist. We can't have that. So let's look at this one. We're just looking at example 3. Each grid on the zoo map has a length of 200 feet. Find the total distance in feet around the zoo. Now, what is it asking for when it's asking us to find the total distance. What is it asking us for? Around. When it's asking us to find the total distance around. Lucy? We know it's what? Perimeter. Exactly. It's talking about perimeter because it says around the zoo. It doesn't say what's the area in the zoo or anything like that. It's talking about around the zoo. So I nicely color-coded it because I love color coding. We have this in our book. So the side that has a length 10, we basically just started going all the way around. You see my nice little thing? We started going all the way around. We started our first point, 0, 0, go to 0, 10. 0, 0 to 0, 10. What's 10 minus 0? What is it, Mario? 10. That's how we get this point, 10. Excellent. Our next point is the monkeys. Here we go from 0, 10 to 7, 10. How do we go from 0 to 7 then, Emerson? We get 7. Then we've got our gorillas. From 7, 10 to 7, 7. We have gone down how many, Hannah? We've gone down 3. Then we continue. Elephants are 7, 7. Tigers are 11, 7. The difference between 7 and 11 is 4. Then we go down again. We've got 11, 7 and 11, 3. The difference between 7 and 3 is also 4. Then again, we have the aquarium. 11, 3 to 7, 3. The difference between 11 and 7 is 4. Then we have 7, 3 to 7, 0. 3 minus 0 is 3. Then we have lastly from 7, 0 to 0, 0. The difference between 7 and 0 is 7. So on my chart, you can see how all of the colors match up with each of the lengths and how we simply followed this way around. Now, the total was 42 when we add them all together. But this is the important part. Each grid, each little box right here means 200 feet. It has a length of 200 feet. So does that mean that our perimeter is just going to be 42? No. What do I have to do to my perimeter, Lucy? Multiply by 200. And what do you get when you multiply by 200, even though the answer is there? So what do you get when you multiply by 200, Anita? We get 8,400 because it's right there. Exactly. Now, let's look at this one. Here. So here, we've been given some coordinates. We've been given the coordinate 0, 1. We've been given the coordinate 0, 4. We've been given the coordinate 8, 4. And we've been given the coordinate 8, 1. So we have to find the difference in length between each side, which I already wrote out for us. Now, the difference is, what are we looking for here? Our x values or our y values? Which one are we looking for there, Liam? On this bottom line, x values or y? What are we looking for? It's not our y, so it has to be our Gloria? X. It is on our x-axis. It is on our run axis. So we're going to be subtracting the x values. What are the two x values that we see there, Jenna? We see 0. And what's our other x value we see at that bottom point? 8. So we do 8 minus 0, which is 8. Similarly, let's look at this side. What am I looking for here? My x values or my y values, Nathan?
Where? Your y.
My y values. What are my y values that are listed there? Let's see. What are my y values, Rafi? 4 and 1 that we see on that side. Excellent. And what is 4 minus 1, Tobias? 3. Excellent. So we have that side of 3. Now, it's asking us to find the perimeter. What's the original perimeter of this shape then? What's the original perimeter? That just means before we take into account this later part. What's the perimeter of this shape that I've given us? Tobias? 22. Excellent. We add up all the sides. This side's 3, so this side is 3. This side's 8, so this side is 8. 8 plus 8, 16. 3 plus 3, 6. 16 plus 6 is 22. But they threw a curveball our way. They said that each unit represents 12 inches. So what do we have to do to that perimeter? What are we going to do to that, Matthew? So if each of these 1 lines is equal to 12 instead of 1, what do you think we're going to do? We are adding something. We are doing that. What are we going to be doing, Diana? Multiply by 12. Exactly. This is what we did in that last lesson where we were doing changes in dimensions. What we were doing is we were going up by a factor of a certain number. Here's perimeter. We're going up by a factor of 12. So what does that mean? Our factor changes. We change by a factor of what? If we're going up, if we're multiplying by 12, we're changing by a factor of what, Anita? 12. That's it. For perimeter, it's 12. So what is 22 times 12 then, Tobias? 264. Perfect. Now I've got a question for you. What about area? Just to refresh, what is area of this shape? What's the area of that shape, Daniel? 24. But now each block is equal to 12. So I'm multiplying each of those sides by 12, right? Just like I did before to find my perimeter. But what happens to my area? Am I just going to multiply my area by 12? What do we think? Yes or no? Are we multiplying our area by 12, Daniel? Daniel says yes. What do other people say? I mean, the other option is no. So do we have anybody who says no? So everyone thinks we're just going to multiply our area by 12, right? Let's check that. Got my nice little rectangle. And I had it 8 and 3. And my area was 12. Or my area was 24. But now I'm increasing it. I'm increasing each side, multiplying it by 12, just like what Diana said with our perimeter. So I multiply each side by 12. What is 8 times 12, Michelle? 96. And then what is 12 times 3 then, Rafi? 36. So what would our new area be if we wrote it out? It would be 96 times 36. 96 times 36. I'll give you guys a second to solve. So let's see when we multiply. When we multiply, Anita, what's 6 times 6? So we get a 6 here, we bring our 3 up. What's 6 times 9? 54 plus that 3 makes it a 57. Magic 0. Let's see. I want Nathan. What's 3 times 6? 18. Then what's 3 times 9, Nathan?
27.
Plus that 1 makes it 28. We get 6. 15, so we carry that 1. Then we get 14. Carry that 1, so we get 3,456. 3,456. I don't know about you, but that looks a lot more than times 12, like Daniel and most of the class thought. What is it times then, Michelle?
288 squared.
Here's how we can check how the factor is. Let's just do some division. Let's do our division. So I'm going to do some long division here. I've got 3, 4, 5, 6, and I got 24. We get 10. We bring it down 105. It can go in 4 times. That is 96. That would be a difference of 9. We bring down our 6. Hey, we already know how many times it can go into 96. If 8 times 12 is 96, 24 is 2 times 12. So it's going to be half of 8. So we get 4. So this one is times 144. That's seemingly unrelated, right? Where did this 144 come from? Who can tell me, Daniel? 12 times 12. 144 is 12 times 12. When we're doing area, when we do area, It increases by a factor of our number squared. So what if I had increased our shape by a factor of 1/3? What would our area be? What would the change in our area be? If I increased it by 1/3, what is the change in our area? I'm not asking for the full area, just what would the change be, Anita?
What if it decreased by 3?
If I'm multiplying it by 1/3, it's the exact same as dividing by 1/3. Or dividing by 3, yes. But what would the change in the area be? Rocco? Not 3. What would the change in the area be? Remember, if it's area, it's going to be our change squared. So what is 1/3 squared then? Lucy? 1/9. What if I decided to change my area by 13? I multiplied each of my sides by 13. What is my change in area going to be? What is the factor change in area going to be? Ben, what'd you get?
The change would be, it'll be multiplied by 13 with the power of 4 or something?
Not 13 with the power of 4. It would be 13 squared. And what is 13 squared, Gore? Perfect. 169. So with area, the reason that we know that it's always that, if I had my x and I upped it by 13, I have my other x and I upped it by 13, it would be changing by 13 times 13, because that's how we find area, length times width. It would be changing by 13 times 13, which is how with area, we're going to get 13 squared. With perimeter, we would only be going up times 13 because we're adding all of the sides together. Now, here's E on page 708. Now, I graphed this shape for us, so we can already see this, but I want you guys as well to graph it in your books. So let's graph that in your books. So Carmen, I want you to graph these points for me, please. So first she's got point 3, then she's going for her next point. 3, 6, excellent. Then she's going for the next one, which is 5, 6, excellent. And then her last point, 8, 3. Perfect. Excellent job, Carmen. And we connect our points together. Boop, 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 boop. What kind of shape is this? Who can tell me the kind of shape that this is? Jenna. Trapezoid. Yes, it is a trapezoid. It has 2 different length bases that are parallel, but those are the only sides that are parallel. The other sides are not parallel. That is what defines a trapezoid. Now it asks us to find the area. We know it's a trapezoid. So what's the formula for area of a trapezoid? What's the formula, Gloria?
1/2 h base 1 plus.
Excellent. Our formula is 1/2 times the height times base 1 plus base 2 in the parentheses. So that is the formula that we learned for trapezoids. It is almost entirely the same as our formula for triangles because we see that 1/2 for triangles and we see that height times base. But this time we have 2 different length bases, so we have to keep that in mind. We graphed it so we know the length. But let's look. The length of this one is 2, the length of this one is 5, the length of this one is 3, and we don't need to know about the other side because it doesn't ask us about our slant. But who can verify? How can you tell me that the distance between A and B is 3? How can you confirm that for me, Ben?
Because it's counting 3 units, but I have a different question.
How do we do it, Elsie?
I think we figured it out because since it's going up the y-axis, we subtract both of the y-axis.
Yes, we're subtracting the y-axis, and our y is a 6, and our y is a 3. 6 minus 3 is 3. Excellent. Now I want to find the distance between B and C. How do I find the distance between B and C then if I'm finding that? What do I do, Lucy? Exactly. She noticed they both have the same y, so we have to subtract the x. And we know we're running, so we have to subtract the x. For this x, we have a 5. For this x, we have a 3. 5 minus 3 matches with our 2. Lastly, with this slant, we don't measure our slants. Do we care about the slants in this? No, even with triangles, we don't look at the slant. We only care about base times height. Only with perimeter do we care. So now we want to measure, lastly, our last base. So how do we measure our last base? How do I measure this, Fernando?
D and A.
Yes, to get from D to A. Perfect. I subtract 3 from 8 because it's the run value. It's our x value. So I take the x value and our other x value. 8 minus 3 is 5. So then we would fill it into our formula. Our area is going to be 1/2. Our height is 3. Oops, I'm writing height. Our height is 3. It's a 3. And our base 1, remember, doesn't matter, is 2. Our base 2 is 5. Does not matter. Does not matter which one that you pick. So, then I want you to solve. Diana, what'd you get?
I don't have an answer.
Oh, you don't have an answer?
Is that a 9?
That's an attempt at a 3. I have now fixed. Hannah, what'd you get as your answer?
I got 10.50.
10.50 or 10 5/10. Do we agree?
Yeah.
Yes. So we found that by going through the problem just as we know. 2 plus 5 is 7. We've got 7 times 3 times 1/2. I always love to cancel out my halves, but there's nothing good because there's no even numbers here, so I just kind of go along with my problem. If there's an even number, cancel out that half. Just divide by 2. If there's no even numbers, just wait till the end. 7 times 3 is 21, and 21 split in half. I like to do it a way that you guys might not like it, so don't think that you have to. But I have 21 split in half. I split it into 20 and 1. What is 20 split in half then, Anita? 10. Tobias, what is 1 split in half? Yes, 1/2. So I get my answer to be 10 and 1/2, or 10 and 5/10, or 10.5, although we're supposed to use academic language. So we get our answer to be 10.5. Exactly. So we go here to our guided practice. I want you to find the length of each side of the rectangle. So in this case, I want you to find the length of side LM, the length of side MN, the length of side NP, and the length of side PL. Same thing here. We would have length of side PQ, length of side QR, length of side RS, and length of side SP. All I did was I went around. PQ, awesome, first one. QR, awesome, second one. RS, awesome, third one. And then SP, awesome, fourth one. As we know, there are the 4 things. So without even graphing, I want you guys to tell me and find the length of these 4 sides. Once you find it, go on to number 3. Rocco, what is the length of LM? Perfect, it's 2, because the difference, they both have 3s, we don't care. So we've got the difference between 3 and 5 is 2. What about MN then, Rocco? 4, exactly. They both have 5s, so I don't care about my 5s. The difference between 3 and 7 is 4. Hey, let's look at this again. Now, line NP. They both have 7s. I don't care. The difference between 5 and 3, we already did that. It's 2. And so lastly, the difference is 4. Excellent. Adriana, what about number 2? What's the length of PQ? We get... Perfect. It's 3 because zeros, we don't care. And to go from 3 to 6 is 3. What about from QR, Adriana? Let's think it. Q, R. We both have 6s, so they don't matter. Now we're left with our Y values of 0 and 7. What's the difference between 0 and 7? What's the difference between 0 and 7? 7. Easy as that. I love the snarky of course it's 7. I love it. Of course it's 7. Then, of course, RS. Again, the difference is 3, and SP, the difference is 7. Mr. or Mrs. Peel is building a fence around the perimeter of her yard for her dog. The coordinates of the vertices are 0, 0, 0, 10, 5, 10, and 5, 5. So what is the length of our sides first? Side 1, 2, 3, 4. Side 1, we went up 10 feet. Side 2, we only went 5 feet. Side 3, we did another 10, and side 4, we did 5. But, Lucy, what is the perimeter of that yard for her dog? Exactly. So it is 3,000. Our original perimeter with the shapes that we've gotten is 30. 10 plus 10 is 20. 5 plus 5 is 10. Together we get 30. But we know we have to multiply it by 100. 30 times 100 is 3,000. Your homework is page 709, 1 through 8. That is one problem on the back of your page.